So in this video, we're going to see a problem from exercise 10.3, which belongs to chapter number 10, circles, and we're going to see a problem number 3. So let's read what the problem is. Okay. So if two circles intersect at 2 points, so here is the diagrammatic representation, circle 1, circle 2, intersecting at 2 points, prove that their centers, so this is center 1, this is center 2 of both the circles, prove that their centers lie on the perpendicular bisector of the common chord. So if this is the common chord, and if you try to draw a perpendicular bisector of this common chord, so something like this, okay. So if this, let's say, is a perpendicular bisector of the common chord, then we have to prove that even the centers, these two centers of both the circles, will lie on this perpendicular bisector of this common chord. That is what we have to prove. So let's see how the proof can be done. Let's come down here. Okay. So step number 1 is going to be, I'm going to use this space. Okay. So step number 1 is going to be, now we have not named the centers. Let's call this center as A, and let's call this center as B, and let's call this common chord as P, and this as Q. Okay. So draw a line perpendicular from center A, to the chord PQ. Okay, this is the first construction that we're going to do. So yes, let's take a different color. So let's try to zoom in. From this center A, we are going to draw a perpendicular line to this chord PQ. Quite a simple and straightforward construction. So let's do it. So this will be our perpendicular from the center A to the chord PQ, and this is how we are going to mark that it is a perpendicular. Let's say it intersects PQ at point M. So I'm just going to write here M. So yes, this is my point M. So this is our point M. Now we know that we have a theorem. If we draw a perpendicular from the center to the chord, then it will bisect the chord. So here is that theorem, just for a quick reference. Let's get rid of this. Yeah. So let's read it. The perpendicular from the center of a circle to a chord, perpendicular from the center of a circle to a chord, bisects the chord. Okay. So this construction of ours AM is going to bisect the chord. What does bisect means? It is going to bisect into two equal parts. Okay, which means that M is going to be the midpoint of our chord PQ. Okay. Now look at this line AM. AM is perpendicular to PQ, and AM is also bisecting the chord PQ, which means AM is the perpendicular bisector of PQ. Okay. So thus, I'm trying to zoom out. Okay, let's do one thing. Let's write this here A, closer to it. Okay. So thus we can say very confident. Sorry. Yes. Okay. So here, so point number 2. Thus, AM is perpendicular bisector. Okay, perpendicular bisector of chord PQ. Okay. Now similarly, now once again we are going to repeat the same process, but from the center B, from center B of this circle. So again, I'm going to do my step number 3, which is going to be draw a line perpendicular from center B this time, from center B to chord PQ, Okay. Once again, this theorem will apply. Okay. This theorem will apply that if you draw a perpendicular from the center of the circle, to the chord, it will bisect the chord. Which means, let's zoom in again. Now, if I try to draw a perpendicular line from the center B, okay, towards chord PQ, then it has to come at the point M. Okay, it will intersect at point M exactly. Okay. Okay, and thus this BM will again be a perpendicular bisector of PQ. Okay, so let's come here and make that statement. So thus BM is also a perpendicular bisector of the chord PQ. Okay. So these two statements are very important. I'm just going to highlight them. This as well as this. Okay. So we have AM, this AM as a perpendicular bisector of PQ, and we also have BM as a perpendicular bisector of PQ, and M is a common point. M is a common point between these two perpendicular bisector, which obviously means that A, M, B are collinear points. Okay, because A and B should lie on the same one single line that passes through this midpoint M. Another interesting fact is, if you do the summation of these angles here, AMP and BMP, 90 plus 90 is going to be 180 degree. So if the summation of two angles is 180 degree, it means that these three points are collinear. And why is the summation is equal to 180 degree? Because we know this is perpendicular, so it's 90 degree. So 90 plus 90 is going to be 180. So that is another way to look at it, that how these 3 points will be collinear to each other. So that completes our proof, which says that prove that their centers lie on the perpendicular bisector of the common chord. So obviously this A and this B lie on the perpendicular bisector of this chord PQ, and this completes the proof.